All right, geometry boys and girls, it's time for some Geometry Excellence Television. Here we go. So, given complementary acute angles, students will be able to prove that the sine and cosine, ooh, good, more trigonometry, I love that, of the angles are equal by comparing ratios. All right, first, how could you write the objective as an equation? All right, so that would mean that the sine of one angle, let's call it A, equals the cosine of the other angle, like that. So, what the world is this? We're going to find out. So first, if A and B are measurements of complementary angles, complementary means they add to 90 degrees, then we're going to show that sine of alpha, or angle alpha, equals cosine beta. Those are Greek letters, so that's why I'm saying alpha and beta rather than A and B, because the Greeks made up a lot of this stuff. So we're going to use their alphabet. So in right triangle ABC, the measure of acute angle A is denoted by A, and measure of acute angle B is denoted by beta. Okay, so that's what basically says what we were talking about. So now let's look at this picture here. Okay, so I'm going to fill out this chart. Sine of alpha, sine of beta, cosine of alpha, cosine of beta. All right, first thing. Sine of alpha, cosine alpha. So here's alpha right here. So let's label our triangle. So here is hypotenuse, opposite, and adjacent. Okay. So sine of alpha, that is the opposite over adjacent. So that looks like, sorry, opposite over hypotenuse, my bad. That's A over C. Cool. All right. Now what do we have? We need to find the cosine alpha. Since I'm looking at alpha as my reference angle, I'm going to stay here. I'm going to skip over this one for right now. So that's going to be A alpha, so it's B over C. B over C. Okay, cool. So let's get rid of all of this, because now I'm going to change my reference angle. My new reference angle is going to be beta right there. Okay, so new reference angle is beta. What am I going to be looking at? Woo! Right here. So now here is the hypotenuse, here is the opposite, and here is the adjacent. Okay. So sine of beta, that's the opposite over hypotenuse. So that is B over C. Cool. What's the cosine of beta? That's the adjacent over hypotenuse, because we have so, ka, toa. I've memorized this, but you can do it. You can write that out if you want. Adjacent A over hypotenuse. Boom. Okay, so now we fill this out. What can we conclude? Well, look, A over C here and A over C here. So I conclude that sine of alpha equals cosine of beta. Cool. What else do we know? We know that sine of beta equals cosine of alpha. Woo! Because that's B over C and B over C. Cool. All right, looking good. Let's try and do some of this. So consider the right triangle ABC, so that angle C is a right angle. Okay, got that. And the degree measures of angle A and angle B are alpha and beta, respectively. Okay, find alpha plus beta. So what are these two angles? Well, that's easy, because if this is 90, these have to add up to 90. Like this could be 45 and 45, which adds up to 90, or this could be 30, this could be 60. They all add up to 90 no matter what it is, because all angles add up to, in a triangle, add up to 180. So this equals 90. All right, now let's try B. Use trigonometric ratios to describe BC over AB. Okay, so here is BC, here is AB. Right? This is where I'm focused right now. So look at alpha right there. Okay, SOHCAHTOA, write it in if you need. So I'm right here. What's the indicated side? We got this side and this side. That looks like it is the opposite and hypotenuse if alpha is our reference angle. So alpha, so that would mean opposite over hypotenuse. That's the sine. So sine of alpha equals BC over this part right here, hypotenuse, AB. Cool. So I want two different ways, so I need another way. All right. So let's get rid of this and draw it again in your notes if you need. Okay, so I want BC and AB. So let's use a different reference angle. Let's use beta right here. So this is the hypotenuse, obviously. This is the opposite side. This is the adjacent side. So now I'm given the adjacent and hypotenuse. So that's now going to be cosine of the other angle, beta. So that's going to be BC over AB. Got it. Okay, looking good. Let's try one more. Okay? So let's try this. Part C. AC over AB in two ways. Ooh, okay. So let's bring this down here. So I want AC and AB. All right, so AC right here. Sorry, get the pen. AC and AB. Like this. In two different ways. So the first one, I'm looking here at alpha. What do I have? Huh? Oh, yeah. So this is going to be opposite, hypotenuse here, and adjacent. Okay, SOHCAHTOA. So I want AC over AB. So now if I'm looking at this, it's going to be adjacent over hypotenuse. Those are the two sides I want. So adjacent over hypotenuse, that's going to be, so the cosine of alpha equals AC over AB. Got it. Okay, what else do we need? We need to know that, ooh, beta. Okay, so what if I'm looking here? So now AC and AB are these. So if beta is my reference angle, that would mean this is the opposite and this is the adjacent. Hypotenuse stays the same. So now this is the opposite right here. So this would be, if I'm looking at beta, so I have opposite and hypotenuse. So that's going to be sine. So sine of beta equals AC over AB. I think we're noticing a pattern. The cosine of one angle equals the sine of the other angle. Cool. All right. So we're looking at the patterns, looking good. Last thing we're going to do is this, 2a. So find the value of theta. Theta is an angle that makes each statement true. Okay. So check it out. So we got this. So one angle is 25, the other angle is theta according to this problem. So what does that say? Okay. So the cosine of this angle, so cosine of this angle of 25, that's going to be adjacent over hypotenuse. So that's this and this equals the sine of this angle. Because that's true, right? Because now this is the opposite. This is the hypotenuse. Boom. So what is this angle? Well, that would be 180 is what all three angles add up to. So that equals 90 plus 25 plus theta. So I can subtract 90. And so 90 equals 25 plus theta. So that would be subtract 25, and I have 65 degrees is theta. There you go. So sine of 65. Boom. So pretty much when we do this, and you have sine and cosine, both of these two angles, 65 and 25, are complementary. So B, sine of 80, is cosine of 10, because 80 and 10 are complementary. Just like this. Let's look at this one. Let's try this 2b. What is if the cosine of 45 equals the sine of what? 45 plus what is 90? Oh yeah, 45. Now you got it. Good work. Okay, so now it's time to practice. Good work. So here's some practice right here. Make sure you practice well. Raise your hand if you have any questions. Remember, the sine of one angle equals the cosine of the other acute angle in a right triangle. Good work. Ready, set, go.